Hello and welcome to our first lesson in Chapter 2, where we discuss linear equations in one variable. In our previous chapter, we discussed how real numbers interacted with each other and operations that you can perform on them. In Chapter 2, we're going to look at equations involving variables, numbers that we just don't know what they are, and try to solve and figure out what they are. Now, these are what you would call just expressions. They're numbers with variables, but they don't really necessarily mean anything. It's not until we add an equal sign that we actually turn these expressions and they become equations. With equations, you can actually manipulate it and show how one thing relates to another. In this case, y relates to 18 by being 4 more, in this case, than 18. Or 18 is 4 less than the variable y. That gives us a little relation between y and these other numbers. They can be far more complicated, as in the second one, where we have this long, complicated equation of 6 different variables. No real idea what they are, except that we can punch in numbers and find out, we've got this. If we know what, say, x, y, and z are, then we know that if, by plugging those in, we can find what j, k, and l are with a little bit more information. So, what specifically, though, makes an equation a linear equation in one variable? Well, linear equations in one variable generally are of the form ax plus b equals c, where a, b, and c are just real numbers and a doesn't equal 0. So we're just saying that this is just an expression, or an equation that relates x to numbers a, b, and c. And through this, you can solve for x to find if you're given a, b, and c, and know, so this is what the value x is given this certain setup. Now, the biggest thing to remember is this is a linear equation. And the main reason you can know it's linear is the x is all by itself. In the previous expression we had on the previous slide, we had, x to the 4th, y to the 8th kind of equation. Linear equations always are in a single point, where in this case it's like x to the 1 right here. X will never be, in a linear equation, there is never something x squared or x to the 3rd or even to the 8th. It's always just x all by itself. Now, to solve, we need to go through a couple of properties first when it comes to equality. So let us suppose that we just have these two things, a and b, and we know they're equal. We don't know what they are, we're just saying they're equal. They're equivalent. So that means if a and b are equal, we can add a number to both of them, and our equality stays the same. So in this case, we add c to both sides. And by doing so, the left side still equals the right side. For multiplication, it's the same thing. If we take the left side and the right side and multiply them both by c, they're still going to be equal. This also is true for the opposite, in which case we can subtract c from both sides. Subtract some number from both sides and still get the same equality. They'll stay the same, including dividing. We can divide by some number c and we'll get the same number, and the equality will still hold. Of course, you also have to be careful that C, of course, C cannot be 0. Obviously, we cannot divide by 0. So if C is 0, we've got a large problem, and that's something that just can't happen. The biggest idea here is that for equality to hold, A equals B, whatever you do to the left side, you must do to the right side. If you subtract C from A, you've got to subtract C from B as well. Now, to solve a linear equation, there are 5 simple steps that you just have to follow. Step 1, clear fractions or decimals. This is more of a simplification of steps. It's a lot easier to solve when you're not dealing with a lot of fractions or decimal places. If you can, you want to deal with whole numbers. It's just easier. And just, you want to solve these things, and you want to solve them easily. So that's the first step. Then you're going to simplify each side separately. So we're going to look at we're always going to have, since this is an equation, you're going to have stuff equals more stuff. So we're going to simplify, but we're going to look at simplifying each side on its own. So you simplify the left side first, and then you simplify the right side. Once you do that, then you go to step 3. Isolate the variable terms on one side. In most cases, it could be x, it could be n, it could be k, but whatever variable it is, and in most cases we'll be dealing with x, you're going to make sure to take x and we're going to move it all to one side. So if x is on the left and the right, we need to move everything from the right side, and we're going to move it, all of the x variables, and we're going to move them all to the left. And the best way to do that will be to do either add that same number or subtract that number, so that way it disappears from the right and is moved to the left side. And we'll see that in an example later. Once we have all the x's on one side, now we want to isolate the variable. We want to get x all by itself. And to do that, you're going to move any extra terms that are kind of grouped with x, and you're going to move it over to the right side, so that way only thing that should be done on the left is x, and everything on the right should be your answer. So we finally come up with an x equals answer. Now, obviously that sounds like that's the final step. Obviously, x equals the answer. So what? But there's 5 steps. What's that last step? Well, the last step is to check it. Once you know what x is, go back to that initial equation or that you looked at the very beginning before you even did any steps. Plug in your answer and just double check. Does it hold true? If it does, then good job. Then you've got the right answer. If it didn't, then there was a mistake in one of your previous steps. In which case you just go through and just double check it, either looking at each step again or just starting from scratch and just seeing how it works all by itself. So, as an example, we're going to look at this equation: 6/100 x plus 9/100 of 15 minus x equals 7/100 times 15. Step 1, clear fractions and decimals. In this case, we have decimals. The easiest way, of course, to get rid of the decimals is to multiply this entire thing by 100. Whatever we do to the left, we're doing to the right. So we're multiplying both sides by 100, and this will still stay equal. Now, the reason why we do 100, of course, is because each of these we'll make the decimal move over 2 places. Here, here, and then of course here. Now obviously some of them could be, if this was like 0.7, then it still moves at 2, and so instead of being 7 it'll become 70. You just want to make sure to multiply both sides by a large enough number, either 10, 100, 1,000, whatever it takes to get it where everything is all numbers. And in this case, now we've simplified our equation to 6x plus 9 times 15 minus x equals 7 times 15. That's a lot simpler and a lot easier to look at it to solve than what we were utilizing before. So now we're on to step 2. Step 2, now we need to simplify each side. So we're going to do each side separately. So the first thing we're going to do is, let's do the left side. Well, easiest thing to do there is we're going to distribute the 9 to the 15 and the x. And by doing so, we get now 6x plus 135 minus 9x. As you can see, what we did is we just took the 9 and I distributed it to the 15 and to the minus x. So 9 times 15 gives us our 135, and 9 times minus x gives us our minus 9x. Simplifying further, well, we just take 6x and we subtract 9x, and that gives us our minus 3x, and our 135 is still there. So now we've simplified the left side. We need to now simplify the right side. 7 times 15. Well, luckily that's easily done in a single step. Well, 7 times 15. You can use your calculators and double check that is 105. Now step 3, we need to isolate the variables on one side, in this case x. Well, we're done. There's no need to actually, in this case, and this will happen occasionally, step 3 is an unneeded step in this case. The only variable here, x, is already on one side. There's no x's over here that we need to move over. So, good job, we're done. At least with step 3. Now we need to go ahead and move on to step 4. Where we need to isolate the variable. We need to isolate x. So, first thing we need to do is we're going to do one of 2 steps. One thing you can do is we need to either get rid of the negative 3 here first, or we need to get rid of this plus 135 first. Either way will lead you to the same answer. 99 times out of 100, this is going to be the easiest thing to do first. You want to get rid of the addition stuff first. This involves dividing the entire thing by negative 3, which can make it get a little bit nasty. This just involves subtracting 135 from both sides, here and here. Much cleaner than having to divide by negative 3. So the best thing to do will be, in this case, is to subtract 135 from both sides. And the reason for this is because we're doing minus 135 to both sides. It's staying equal, and it gets rid of the 135. So we have plus 135 here and here, but now that we subtract the 135, it's gone. So all that's left is minus 3x. Over here, we have 105 minus 135, and that simplifies to negative 30. This is why it's usually the best thing to do first, because now we need to isolate x by dividing both sides by negative 3, which, if you can see, is a lot cleaner than if we'd have taken 135 and divided by negative 3, 105 divided by negative 3, and then we have fraction and a fraction. It gets messy. This makes it, in this case, very clean. So all we have is, after dividing both sides by negative 3, you get x all by itself, and then negative 30 divided by negative 3, which simplifies to 10. So that means our answer is x is equal to 10. So now we just need to do our final step. We need to check it. So we just go back to our original equation, and we're just going to plug in 10 here and here. So we have 600ths times 10 plus 900ths times 15 minus 10. So we're going to simplify everything. You get, from here, you get 0.6 or 6/10. Here you get 15 minus 10, of course, that simplifies to 5. Simplifying further, we get back to 9 times 900ths times 5 is 4500ths. 700ths times 15, that's 1.05. And then in our final check, we're going to do 6/10 plus 0.45. And as you should see, if you don't see it already, 1.05 is equal to 1.05. And this is how you know that our answer was correct. The left side does in fact equal the right side. Well, this concludes our lesson for 2.1. Don't forget to look at any of the review problems I have posted on the web page. If you do have any questions or comments about anything in this section, feel free to post either to this video on YouTube, or you can post in the discussions within section 2.1 on the website. For further review, click on either any of these 3 links to go back to any particular section and to review anything, just to follow along again. And I will see you guys in class next time.